Good morning, grade 10s. So today, when we start our lesson, we're just going to do a little recap of solubility. I know when I video chatted with you guys, we did one of these examples, but we're going to do a couple more because this is a key piece to skeleton equations, which is what we're learning today. So to check our solubility of ionic compounds, we are going to use our solubility chart. Okay, so if you don't have it out now, I'd really suggest you get it out so you can kind of follow along and know what the heck I'm talking about. So when I start with this example, the first thing I'm going to do is I am going to take that name and I'm going to write it in a formula so I make sure that I use my right charges. So this would be silver and phosphate, PO4. Now, this is not balanced because silver has a charge of 1 positive, phosphate has a charge of 3 negative. We do need to remember this skill we learned from chapter 2. I know it's been a bit. Okay, so there's our formula, nice and balanced. So what is the state of it? It is an ionic compound, so that means that we need to check this guy out, which means I need to look for my anion, which is phosphate. So it's over here on the far side. And I'm going to try and find silver, and silver is going to fall in the bottom half where it says low solubility. So this will actually be a solid, aka a precipitate. Okay, the next question, copper 2. So that 2 does not tell me that there's 2 of them. It tells me there's a charge of 2, which helps me balance. Bromide has a charge of 1 negative. So I would actually need 2 bromides. So check the state. So I am looking for bromide, my anion, so Br1 negative, and I'm going to find copper 2 positive. Now, copper 1 positive is down below, but keep in mind this is 1 positive. We have 2 positive on our example because copper is a multivalent metal. So it actually falls under the most top part. So this would actually be highly soluble, aka aqueous. Okay, which means easily dissolved in water. Okay, so with that prior knowledge established, we are going to move on to today's lesson, which is skeleton equations. They're called skeleton equations because they're the bare bones. It is your basic equation represented with formulas. This is the important part. And states for both reactants and products. So what happens is you get given it your question in name format. You have to change that name into a formula and then also include your states. The one nice thing about skeleton equations is they are not balanced. You do not have to balance them. You will eventually, but bare bones skeleton equations get to just stay as they are. Okay? So this is an example of one of them. So here's your word setup, your sentence. So silver reacts with bromine to form, tells us that there's a chemical reaction happening. Silver bromide. Okay, so this is your products. And these are your reactants on the other side. So what this would look like is I see silver, which is my element, and the state is solid. We'll get into how I know that. Bromine is 2. There's a reason it's 2. It's diatomic like oxygen. Also, we'll get into that. And liquid, it forms, hence the arrow, silver bromide, which is our nice compound. And you'll notice this is a balanced compound. You don't get away with forgetting about balancing just because we've moved on from chapter 2. Okay, so how do I figure out the state of my each one of my formulas? Okay, so we will end up using our solubility chart, but that doesn't work for everything. We need to look Add a couple different things that we could end up seeing. This would be something important to write down in your notes. Super duper important. So elements, if you just get a plain element on its own, so for example, silver, I would just find silver on my periodic table, and I'm going to look on my sheet, and I'm going to notice that silver, and there it is shaded in kind of grayish. And you'll notice that grayish means that silver is a solid, okay? So we use elements, states that exist on the periodic table because that is the state that happens at room temperature. All right, so for example, if we were to do another one, you'll see oxygen, O2. It is in gas state. We know that, but believe it or not, our periodic table also tells us that in gas state. Okay, we only have two liquids, which is our mercury and bromine, only two that will end up being in that liquid state. So if we are looking at an ionic compound and it is not in solution, it is automatically just a plain old solid. You cannot assume a product is not in solution. You actually have to figure it out. So I'll explain what I mean by that a little bit more as we go on to examples. If an ionic compound is in solution, this is where our solubility chart, that skill we just went over, comes into play. And then the last thing to keep in mind is just that we end up with sometimes what we call a combustion reaction. And combustion means, hey, fire, woohoo, heat. And heat means that water is not going to be in liquid state. Water is actually going to be in a gas state. So we have to keep that in kind of the back of our heads. Okay. So some key important pieces that we need to know and need to remember. So we need to remember and memorize our diatomic and polyatomic elements. They are the following. They do not exist on their own. So for example, these are the only elements that when they show up, they do not just exist. So phosphorus doesn't just exist as P on its own as an element. It always exists as P4. But any other elements that do not fall in this category, hence they are not diatomic and not polyatomic. So for example, let's say, you can pick any one you want, but let's say zinc. Zinc is an element, but it does not fall in this category given to you. So therefore, we'd actually just write zinc on its lonely old self. If I was to pick silicone, silicone does not exist in this diatomic and polyatomic element group. Therefore, I just write Si on its own. But if in your word equation it said nitrogen reacted with oxygen, you would not get away with just writing nitrogen. You'd actually have to write N2 plus O2. Okay? And then you still get to use the states provided on your periodic table. Okay, so how do we remember this? This is a trick you actually learn in grade 10, and it carries through into Chem 20, and you keep using it all the way throughout whatever you decide to go into Chem. And that is a little trick we call Hofbrinkel the clown. I do not like clowns, but it's catchy, it works, and all our high school teachers use it. So, Hofbrinkel the clown. This is our little acronym to remember all of the elements that are diatomic. So Hof, so your hydrogen, O is your oxygen, F is your fluorine, Br is your bromide, I is your iodide, N is your nitrogen, and Cl is your chlorine. But we can't PS, don't forget the shoes, because PS stands for phosphorus and sulfur. Okay, so now these, and this is my other little, these are all twos. So if these are all diatomic, 2 times 4 is 8. So PS, don't forget your suits. Hofbrinkel the clown. Little way, if you want to come up with your own May, I don't care, go for it. You're going to end up hearing and probably more than once. Okay, so what do these skeleton equations actually look like now that we kind of know our rules and guidelines for states? So here's your word problem. So we have oxygen reacts with iron. Formation, that means that we get a reaction there, and we get iron 3 oxide. Okay, so this is our product, this is a reactant, and this is a reactant. Okay, so I have oxygen. Oxygen falls under those diatomics that I was just talking about. So O2 reacts with, we use that with a plus sign. Iron is just an element on its own. It does not fall under diatomic and polyatomic, so it's just one of them. Arrow, it's forming iron 3 oxide. So I do have to, sorry guys, I'm trying to get a different pen color here. I do have to write this compound properly. It says 3 plus and oxygen is 2 negative, so I have to balance this. So iron, this should be iron 2O3. Okay, so there is all of my beautiful formula work that we spent time doing chapter 2 on. But now I need to think about my states of which one's which. So if I find oxygen, it's an element. Oxygen is a gas. Okay. Iron, it's an element. I find it on my periodic table. It is a solid. And then this guy, because it does not say that it is not in solution, we are going to therefore check our solubility chart. And so we have O2, which should be, where is he? Okay, so he is not on here, which means that you actually get to assume that it is an ionic compound that is a solid. Okay, so if it's not on here, ionic compound, solid state. All right. Next question. If you want to try this one, go for it. Pause. If you want to watch me do one more, watch away, and then you can try the next one. Okay, so we have aluminum metal. Right off the bat, this actually tells us that the metal means it is a solid. Okay, it's placed in a beaker of sulfuric acid. So that means it's mixed with sulfuric acid, and it produces, so that tells us it's our arrow, hydrogen gas, and aluminum sulfate. So to break that down, I have aluminum. Ooh, that's a nice A. Aluminum plus sulfuric acid. Oh joy, we have to remember our acid naming. Of course we do. You didn't think I'd let you forget about acid naming. So sulfuric acid. So we find our ic acid on our table. Okay. And we jump over, change it into, it says hydrogen 8. So that means I'm looking for sulfate. Okay, so I'm looking for hydrogen, sulfate, and sulfate is a polyatomic because it has an 8 ending. So this is actually going to be HSO4. But wait, sulfate has a charge of 2 negative, so therefore H2SO4. So if this naming and recap review has thrown you off, because I know it's been a little bit, you will want to go back and maybe find that naming and formula review sheet I gave you and do some practice on it, because this is key to understanding and getting your skeleton equations right. Okay, so aluminum mixed with sulfuric acid produces hydrogen gas. Hydrogen is Hofbrinkel. It fits into that diatomic, so it's H2. And it produces aluminum 3 sulfate. So aluminum is Al, charge of 3 positive. Sulfate is 2 negative, so I need to balance this. So Al, I'm going to run out of room. 2, I'm going to need, Ooh, it will let me write in here. Nice, okay. And I need 3 of these. Because I need more than one polyatomic, I need to put brackets around it. Okay, so now all my formula work, and I'm going to do my states. So aluminum metal means it is a solid. An acid, we know, means it's an aqueous state. It says hydrogen gas, so I don't actually even have to think about that one. And the biggest one we have to kind of consider is that aluminum sulfate. So sulfate falls under, right there, SO4 2 negative, okay? And I'm going to find aluminum in the most on the top half. So this is going to be an aqueous compound. Okay, so I am going to, if you want to pause it, I'm going to erase and put 3, 2, 1. All right. I'm going to do one more. Once again, if you want to try this, go for it. Pause, and that way you can play and keep going with it. Okay, so we have ethanol. You don't necessarily have to memorize ethanol. This is one of the ones that I would give you. So C2H6O. It burns in the presence of oxygen. So that means you see burns in the presence of, that's a plus oxygen all the time. Okay, O2, because oxygen is diatomic, Hofbrinkel, and it's forming, so there's our arrow, carbon dioxide, CO2, and water vapor. All right, so H2O or HOH. Now, states, ethanol is a liquid, burns in the presence of oxygen. Oxygen is a gas. Carbon dioxide is also a gas. And it says water vapor, which means we're dealing with steam, not a liquid. So we also get a gas present in this one. Okay. We have one more. Yeah. Okay, one more. Try it, pause it, go for it. Silver nitrate, AgNO3. Check to make sure this is a balanced compound. Silver is 1 positive, nitrate is 1 negative, so therefore it's balanced. Reacted with, this is our plus, salt water. Okay, so salt is one that you need to know, and salt is sodium chloride. Okay, salt water means it's actually, I'm going to do this one right off the bat, that means it's in solution. Okay, so aqueous, to form, there's our arrow, silver chloride, so AgCl, check to see that this is balanced. Silver's 1 positive, chlorine's 1 negative, balanced. And it says sodium nitrate, so NaNO3. We also have to check the balance of this guy. Sodium's 1 positive, nitrate's 1 negative. Life becomes a lot nicer that way. Okay, so the last thing we need to do is check our states. So silver nitrate is reacted with salt water. So it does not say in solution. Usually it does when you get your reactants, but we're going to check. So silver nitrate, NO3, has high solubility. So this is aqueous. Okay. We already know that if it's with water, it's an aqueous state. So we're going to check silver chloride. Chloride is right there. Okay. Silver, drop it down, Ag positive. So this is your precipitate actually in this question. It's a solid. And we're going to check nitrate, NO3. Sodium fits under the all in the top. So this is aqueous. Okay. These are common gases you do need to know, so I would really highlight or write them down. This one, carbon monoxide, you already know that one, okay? Nitrogen dioxide, sulfur dioxide, oh, surprise, surprise, water showed up, carbon dioxide, and this guy I've mentioned in class before, but I know you might not, ammonia, okay? Ammonium is NH4 positive, which is on your polyatomic, but this is NH3, which is a gas. Sometimes you'll also see methane, which is CH4, which is also a gas. So these are common gases that might show up in skeleton equations. Okay, so saying that, that is the end of your lesson of skeleton equations. If you have any questions, remember, ask away, or if you want to hold on to them for our video session this week, it is up to you. I hope you have a good rest of your day. Bye.